So today I'm going to talk about isometric projection. And if you remember last time I talked about how to create an orthographic projection given an isometric. Well, today it's going to be the reverse. I'm going to give you orthographic projections and you're going to try to draw an isometric. So an isometric is just a nice way to see the object because on a drawing it can sometimes be confusing to look at just orthographic drawings. See, these can be kind of confusing with all the dimensions. It can be kind of confusing. So an isometric is just a nice projection to include to make it easier to understand. So there's different kinds of pictorials. So pictorial is the umbrella term, and you have axonometrics, obliques, and perspective views. So the perspective view is kind of like what you see here. It's got vanishing points. Okay, you got a 2-point vanishing point projection, and then you have a 3-point vanishing point projection. So this is kind of like what you would see in real life, because your eye, when you look at things in real life, especially when you look at them closely, it's a perspective view. So a lot of times you use this to render a realistic view of your product. But most technical drawings use an axonometric, which has parallel lines. You see, all these lines are parallel to each other. And there are 3 types of axonometrics: the isometric, the diametric, and the trimetric. And really, it talks about the different angle in between these lines. So the most common one is the isometric. This is the one you use all the time on a mechanical drawing. And you usually keep it on the upper right corner of the drawing. But a lot of times you don't have that luxury. So if you type in mechanical detail drawing, you'll notice that these isometrics are placed all over the place. You got one on the upper left, you got one on the upper right. I mean, they go everywhere. So it's hard to just stick to a standard when you have so many different applications. But try to stick to this. Try to keep it on the upper right as best you can. The next point is, when you project an isometric, try to make it so that you look at it from the top down, and the front is on the left and the back is on the right. So try to stick to that. Don't do this. Yeah, it's showing the bottom. Try to avoid that. I mean, unless you need to show something from the bottom, that's alright, but by default, try to stick with what you see there. An orthographic presentation of your isometric is what you see here. The red is the front view, the green is the top view, and the blue is the side view. So whenever you're counting, you're given an isometric, you're trying to count to figure out how to draw this view. Just look at the colors that you see here. Isometrics are commonly used for assembly drawings because it helps you see the bill of material, helps you see how all the pieces are put together. The scale is going to be like this. We're going to use an isometric grid as opposed to the orthographic grid, and everything's going to be on a 1-to-1 ratio. 1 cube here means 1 cube there. 1 cube here means 1 cube there. So you don't have to go 2 cubes, 2, 1, 2 to 3. I try to make this as simple as possible because, again, my point is not for you to measure or know how to count cubes. I wanted this to be as straightforward as possible. When you're starting out, you may want to draw an oversized box of the object and chisel it out with the details. Maybe that'll make this process a little easier for you. But you don't have to do that if you can visualize the object from scratch. When you try to draw an isometric for an incline, don't try to do trig again. Just count the endpoints. Look to see where that endpoint is. Look to see where that endpoint is by counting the orthogonal grids. And then connect the dots. Find this location, find that location, connect the dots. Don't try to figure out the angle of this. To draw a circle on an isometric, you have to turn it into an ellipse. And the traditional way to do that is to draw a boundary box. You start with the center of the circle, you count the radii, and then you use a compass. You set the focal point to set an arc that is tangent about each of these construction lines. So one arc here is tangent about this and that. This arc is tangent about that and that. And then you do that 4 times, and then you get a projected ellipse of a circle. And then finally, on an isometric, you can add some shading to make it look more round. Because again, the isometric is not meant to be technical. It's not something you use to make the product. It's just view to add clarity. So it's okay to add some shading and things like that to help communicate what it is. But you should not add dimensions. Really, you shouldn't even add hidden lines. Usually you should just have solid lines. So really, an isometric is just going to have visible lines. It's not going to have hidden or center lines. I mean, you can if it's really simple, but most of the time people don't include that because it tends to confuse the user. So let's talk how to draw some of those features using Oswald. Okay, again, remember, everything is a 10 by 10 cube. So nothing should go outside of this cube. You see? It should all stay inside. Alright, to draw an ellipse, I made it easy for you. You just pick the plane, you pick the arc radii, and you pick the start and end angle. Okay, so here's one for the front. Let's see what the shortcut is. T for the top. Let's see, T, okay? I bet side is for the side view, or S. So that's how you do that. You will also notice that there is no hidden or center lines for the isometric. I try to keep this as simple as possible, so you don't have to worry about that. So what I'm going to do now is fire up the exercise sheet for this isometric lecture, and here's what we get. Again, 3 tabs, and we're going to practice drawing an isometric given 3 orthographic views. So I'm going to load my line. I'm just going to use the solid line, and I'm just going to draw and count the cubes for what I see. So it's 3, it's 1, 1, 2, 1, 1, 1, and then close. Okay, so again, I'm just going through that and counting the cubes. Then we got the depth, and it's 3 cubes. 3, and you just kind of project. Just like that. You can snap. Whenever you see that yellow line, that yellow box, that means you're snapping. Okay. At every node, you got to ask yourself, which direction am I going to go? See, I can either go up, to the side, down, up. You will always be given enough clues from the orthographic views to know which direction to go. So you got to double check. You got to traverse this. You got to say, all right, I'm here, which means I'm here, then I go here, and then I go down there. You got to be able to traverse this schematic. So I didn't really do a good job snapping to the grid, so what I'm going to do is I'm just going to do it manually. You see now it's local. See, I didn't do a good job there. So I'm just going to drag it till it snaps to the grid. And there it is. And once you draw on this grid or even on Oswald, I don't encourage you to move the entire drawing, because it's kind of like moving a spider web. Everything's kind of like pinned down to the grid. So if you have to move something, just delete and redraw it. Again, this is just a temporary interface. There are ways that we will learn on how to draw things that can be moved easily, like by grouping, by using other layers. So let's just keep that in mind for now. Okay, so moving on to the second example. Let's try to select a line here. Okay, looks good. The main exercise of this one is to take a look at ellipses. So I'm just going to draw this cube. Alright. So this cube is pretty self-explanatory. I showed you how to do something similar on the previous tab. Okay. But what we have now is a circle. So remember, that's done through an ellipse. So let's say I were to... Well, first of all, there's different ways you can do an ellipse. You can even use the ellipse tool. But it's it's not very easy to use. You gotta kind of know where you're headed, and see, it's not the best tool out there. Okay, there, I got it now. Yeah, that's what it's supposed to be. But it doesn't give you as much control as the 3-point arc tool. I kind of like this one a lot more. So let's talk about that. Like I said on that slideshow, you got to look at where the center is and draw a construction box. Okay, draw a construction box. Or if you can visualize it through the grid, you don't even need to do this part. But anyways, let's pick a 3-point arc tool and then just go 2 points there. One here, one here. You see what I'm doing? I'm drawing 4 arcs. And then I'm going to add a tangent point. Tangent. See, I'm adding a tangent relation on each arc. 2 tangent relations per arc. I'm shift selecting to add this tangency. Okay, and then I'm going to trim because we don't need these anymore. Alright, good. But we are not done, because if you look at this projection, we have a hidden line. And the hidden line tells us that the hole is not a through hole, it's a blind hole. Meaning that when we project this ellipse 1 cube down, so here's the center, we projected 1 cube down, means the boundary is here. If we draw the ellipse for that, guess what? There's going to be a residual edge that shows up. And it's going to be just like this. You see? And that's going to be tangent about this and that. Okay, just like that. So in case that's not clear, here's what I was given. I was given this, I was given that, I was given this. And what I did is 1, 2, 3, 1, 2, 3. I drew this. And as you can see, there's this residual edge that shows up. You see that? This edge is what I drew. So you gotta be careful. If it's a through hole, you're not gonna see it. If it's a blind hole, if it's shallow enough, it's gonna show up. Finally, I have a third example here, and this one's gonna exercise a positive cylinder, which means like a rod or a pin, and that's as opposed to a negative cylinder. A negative cylinder would be like a hole. So we got a positive cylinder and an incline. So we're gonna practice how to draw those on an isometric. So again, we're going to do the easy stuff. We'll start at the ref point. Going to count what we see here. And then here's the incline. Alright, so as you can see, I can see that it goes 1, 2, 1, 2. It goes 2 across this way, 2 across that way, and then I just connect the dots. And I'm going to do that on the other side too. Then we got a flat on the top, which is a 2 by 2. Alright, so now to draw the ellipse for this positive cylinder, again, I'm just using the ellipse tool. You got to snap to the center, right? 1, 2, 1, 2. 1, 2, 1, 2, okay? Then you got to drag at an angle and draw. Again, I do prefer that you use the 3-point arc tool, but just to save some time, I'm using the ellipse tool. There we are. Alright, and then once you have that, you can connect the dots. If you don't want to eyeball it, you can use relations for that. Just add tangent here, add a tangent there. So that's a much cleaner way to connect. But you see something that jumps around because the way I restrained it is not correct. So I gotta fix it. Gotta anchor it so it does not jump when I put my tangent. Okay, so now the back is jumping around. Okay, so it's not perfect. Let's see if we can make it. Okay, there you go. Then let's clean this up a bit. Okay, so I just went ahead and cleaned it up a bit to make it look a little nicer, and that's the final product. Okay, so again, you can update the template with your name, ID, date, and then you can file save as PDF. So PDF, and then you'll get this final product. Okay, and make sure to double check your work. Okay, double check your lines, make sure it all makes a lot of sense. and that's it.